Hello and good morning, everyone. I hope you can hear me all just fine. And I would like to also wish a good evening to our friends in Asia that have a little bit later time right now. Our talk today will discuss Hyperledger Fabric security monitoring based on Hyperledger Explorer. So these are two Hyperledger projects that we connected and used to monitor the security of Hyperledger Fabric. So a little brief overview of our talk that we'll be giving today. So with me is my colleague Fabian Böhm, who is also a researcher with me at our department. And we will first give brief motivations. So why should you actually care about Hyperledger Fabric security? And then go in some more detail on background on Hyperledger Fabric and Hyperledger Explorer before detailing our security monitoring architecture. So how we build the security monitoring for Hyperledger Fabric. And then we will go into even more detail on the processing pipeline. So how about data did we collect? How did we process it? And how did we visualize it at the end? And then we will give a brief live demo of the Hyperstack prototype that we built. At the end, we will go into a question and answer session, as is customary for all presentations here at Hyperledger Global Forum. So why should you actually care about Hyperledger Fabric security? Fabric is trusted to provide security for a lot of critical applications. So, for example, there is the TradeLens platform that I'm sure most of you probably have heard of. Then there's other platforms like WeTrade, OpenIDL, etc., who are all using Hyperledger Fabric in production right now. And so for this reason, it is quite important that Hyperledger Fabric is a secure system and that it can't be hacked easily, especially since blockchain has the reputation that, it can't be hacked among many organizations, which is obviously not the case. And you should never take it for guaranteed that blockchain can't be hacked, because like any software, Hyperledger Fabric is vulnerable to bugs and exploits, and of course also to denial of service attacks. And another important aspect to keep in mind is that the independent operation of these Hyperledger Fabric nodes could potentially also increase the attack surface. So for example, if one of the operators has not configured the node properly, then it might be easier for an attacker to get access to that node, even though you have configured your own organization's node correctly. So this is also something to keep in mind with blockchain security, because you have this distributed system that many organizations operate together. So yeah, I want to give a brief overview of attacks that are known for Hyperledger Fabric. There is a precondition for this, so many of these attacks require that you at least have some kind of access to the network. So for example, you can send transactions to the network, that you can maybe access an API that has access to the network. So you need to have a little bit of access, but not for every attack, of course. So for example, network-based denial of service attack will also work if you don't have any credentials for the network. But for example, to abuse a chain code bug, you of course need to be able to send a transaction, so to have a valid identity on the network and to be able to sign transactions. And regarding chain code bugs, there was also a great presentation at Hyperledger Global Forum 2 years ago by Chain Security, who went into detail on some possible chain code bugs. And yeah, there's also other topics that could potentially compromise the state database. For example, per default, Hyperledger Fabric, if you're using Couch database or CouchDB, it has an unsafe default configuration where anybody can access the state database or even modify it. So you should make sure that that is not configured on your system, or you would expose yourself to potentially inaccurate world state on your Hyperledger Fabric instance. And in addition, there's also the problem that we do not have a Byzantine fault-tolerant consensus algorithm, so you need to basically trust your network participants if you're using like Kafka or Raft consensus. I think there is one in the works currently at IBM that is supposed to become the future standard for Hyperledger Fabric, but it's not in the documentation right now, for example. And I think there's also some custom implementations by some researchers, but nothing official yet, unfortunately. And of course, there's also the issue of credentials theft or compromise that could also happen, which is always something to keep in mind. If you notice compromised, then you could, of course, lose confidential data potentially because somebody else could get access to the blockchain data. So how can we support security analysts in detecting these attacks or in getting a better overview of what's happening actually on the network? So I mean, the issue, of course, is that each organization only has access to its own peer and only a limited view of the network, and that you need to monitor both your own host and the network data at the same time to have like, well, at least some kind of well, idea of what's going on the network. In addition, each node has some very different data sources. So you have, for example, the log data, and then you have the metric data and the actual blockchain data, which you all need to aggregate in some way in order to get a good understanding of what's going on. And of course, the large volume of blockchain data, which depends on your implementation, of course, how many transactions you have in the network. But it might be a bit difficult to keep track of what's going on if you have, for example, 100 transactions per second on your network. And then we don't really have any automated systems yet for attack detection on Hyperledger Fabric, unfortunately. So we kind of need the human domain knowledge as well, but for security analysis. So we need someone who knows how these attacks work in order to be able to identify the attacks properly. So to be able to assist the humans or the security analysts properly, we have to find some visualizations and integrate them with Hyperledger Explorer, where we can detect attacks. So before I go into the architecture, I want to give a brief background on Hyperledger Fabric and Explorer, just briefly, for those who have not had much contact with them, but I assume there will not be many here that haven't had at least some contact with Hyperledger Fabric, probably fewer that know Hyperledger Explorer, but I will briefly explain that as well. So the Hyperledger Fabric architecture has many different data sources, as I already mentioned. There's the ordering service, there's the different peers, who are each running maybe different chain codes that are used for different transactions. And then they have different logging levels, so you can configure if you want info or warning or error log levels. In order to be able to get as much information as possible, you should definitely configure info log levels, for example. On top of that, you have the standard SDK APIs, where you can get the transaction subscriptions and the log data. And then you also have the metrics that are made available via Prometheus or StatSD, but we're using Prometheus for our project. And for Hyperledger Explorer, well, it has a basic sync architecture, so it syncs all the blockchain data into a relational SQL database, so PostgreSQL in this case. And it runs basically a sync service that has a channel subscription and stores all the blocks and transactions in its own database, also the chain codes and the different peers and everything. So this is perfect for analysis, so that we can analyze all the data on the blockchain quickly to run queries on it, which isn't possible with the standard SDKs. So yeah, that's basically the architecture. And then you also have a presentation layer on top, which accesses the backend API. The backend is running in Node.js, and the front end is React, which I will also go into some detail a little bit later in the presentation. And the front end basically just displays the data and runs our visualizations that we also added. So for the security monitoring architecture, this is the architecture that we chose, or that we went with. Basically, the top part is mostly unmodified from standard Hyperledger Explorer. So the PostgreSQL database was just added. We just added some fields there to support the additional data that we were using. The blockchain transaction data is also the same from a standard implementation. And the basic front-end architecture with React and Redux is also mostly unchanged. But we added some new dependencies for our visualizations, of course, which Fabian will explain in more detail. So yeah, we also added access to Docker API and to Prometheus. We used a reverse proxy to proxy the requests to Docker and to Prometheus to get the metrics and log data that we need to display in the front end for our analysts. So yeah, the basic flow is, of course, data collection first, then the pre-processing, which happens in the backend mostly, and then the presentation in the front end, where the data is, again, to some degree processed so we can display it in the visualization, but most of the more complicated processing happens on the server side in order to not bother the client with it. So here's an overview of what we changed actually from the original code base. And you can also check it out in our GitHub repository, which is linked on the slides. Most of our changes in terms of code changes were, of course, in the front end because the visualizations take up a lot of code. We also made some backend changes in order to support the additional transaction properties that we want to show, for example, the transaction size and the actual identity who submitted the transaction, which is data that is not available in the standard Hyperledger Explorer implementation. So we added that. Then we added some notifications for config transactions, because if somebody sends a malicious config transactions, they could probably, well, destroy the network in the worst case. So you should probably know about these transactions, and of course, potentially approve or deny them if you have the appropriate permissions for that. And yeah, of course, for the REST services, we added the reverse proxy routes that I mentioned. So in total, there was about 1,000 lines of code that we had to adjust for that. And for the front end, we added a lot of new files for the visualizations. We added some new lists to support displaying issues from the Hyperledger Fabric Jira. So we always want to know about the latest security issues, of course, on Hyperledger Fabric, so we can see if potentially somebody is exploiting these security issues on our network. So that's something that we display on the dashboard right away. In addition, we also have some modifications to some existing views in order to make them a bit more concise and to give a better overview of the network. And yeah, we also added, of course, connectors to the new backend API routes, which is something we usually do with Redux in the front end. Okay, so that's it for my part. I will now hand over to Fabian, who is going to give an overview of the processing pipeline and give a live demo of our prototype.
All right. Thanks. I think you should mute Benedikt, because we're getting an echo. Okay, awesome. Also, hi everyone. I'll take a look at the data collection and things that Benedikt now just mentioned. Our HyperSec tools collect some additional security relevant data beyond the data collected by the original Hyperledger Explorer project. For example, get an idea of the current performance of the network with respect to transaction throughput. Look at some additional Prometheus metrics. So just taking a look at when a transaction is proposed and when it's on the change, so the duration between that. We also collect gRPC metrics, giving us insight into the network activity and the network status, the network communication between nodes, between peers. And besides these metrics and data directly related to Hyperledger Fabric, HyperSec also is able to collect logs from local Docker containers where the Fabric network is running. We also have access to the Hyperledger Jira issues by security tags and security relevant Hyperledger Jira issues, and also have a static scanner chain code. And during our work to gather all this data, getting it all together, we came across some missing or desirable metrics or functionalities. For example, outstanding transactions would be real nice to see, because that would just allow us to easier detect transaction spam attacks. When we go for all this data that we have available, we need to pre-process all this data before. It's especially important when we are working with the transaction data and the possibly large number of data we need to display when we take a look at that. So this is relevant in the transaction view when we get all this data together. And in the context of interactive visualizations, like a large number or large quantity of data poses a real challenge, and thus we need an efficient way to handle this data without too much detail. And with the data binning or data bucketing, we implement data aggregation approach into this transaction view. So originally, with the Hyperledger Explorer, users specify a time range with a start and an end timestamp within they want to analyze the transactions. So we take a look at the pre-processing and on this slide. Besides this already leading to large data quantities, because we maybe get a lot of transactions for this time range, we include the additional metrics prometoids into the existing view. So this leads us to even more data. So we looked at, okay, what can we do to like aggregate the data in here? So in our adapted transaction view, users can also specify their preferred step size for the data buckets. So the smaller the step size is, the more detail you can get from the data buckets or from the visualizations, but also you get more data buckets when the step size for the visualizations might respond slower. And based on this, we built like our empty data buckets and form as a hash map, where each data bucket has an ID, starting timestamp, the respective transactions and metrics for this time range the bucket is covering. And the timestamp for the first bucket is just to start user input, and the ID of the hash buckets is calculated by dividing the timestamp by the step size and then rounded to the smallest integer. Timestamps of the following buckets is always just the sum of the previous bucket's timestamp plus the user input step size. And this hash map now allows a very efficient population, as you can we exactly calculate the bucket for each transaction or metric where it needs to go to. Therefore, we take the timestamp of the event minus the start user input. So this is kind of a normalization we need to do, divided again by the step size, rounded to the smallest integer. And this gives us the ID or the hash of the respective bucket where this transaction or metric data needs to go to. So we can very efficiently access the data, as we do not need to iterate. You need the data for a specific time, but we can just calculate the hash at this point in time is related to, and then data with a runtime of 1. Okay, that's it for that slide. Benedikt, if you just one, please. Thanks. So we are using well-established libraries on our project to visualize this data. So as Benedikt mentions, Explorer's UI is originated with React. We just stay with React, of course. And a very well-established library to implement interactive is script library 3.js, this data-driven documents. While this is starting code often, it's just a huge spaghetti. And also one other problem with D3 is it doesn't integrate that well with React. But in 2020, Airbnb introduced a pretty cool which expressive low-level visualization primitives based on D3, but very well integrated and combined with the functionality of React. And still, if necessary, all the underlying D3 functionalities are still accessible. So we mainly worked on the network view of Hyperledger Explorer and the transaction view. The main changes on the network view, you can see bottom left side of the slide. We extended this with a node link graph. The graph shows local nodes and also external nodes or peers beyond these two borders. So these are filled nodes you can see, and these kind of mark the border of our local organization. And also we can highlight high frequency links based on gRPC metrics. Like the gRPC metrics are unusual, high frequent or low frequent. We can highlight this. Second main focus, or our second focus, was the transaction view, bottom right of this slide, where we can explore information about the transactions on the chains and the. We added 4 different visualizations. We have this first chart just displaying the number of transactions within each data bucket that I explained earlier. And then we have 3 more fine granular charts. On the left, we have transaction count per MSP per bucket. In the middle, we have the average transaction size per MSP per bucket. And on the left, on the right, sorry, we have the average processing times of transactions. And on the bottom is the part of the original Hyperledger Explorer, a table with additional detailed info about the transactions. And how this is all working together and how it's looking interactively, we just take a look at a quick video, a quick live demo. So we start with our little overview at the main landing page of the Explorer. So this is the dashboard. We get some high-level data about our small test network consisting only of 2 peers. Besides all this other data, we have the Hyperledger Fabric Jira issues, including some details, the descriptions, and also a direct link pointing to the issue. Next, we'll take a look at the network view, which gives us more information about the active peers in the network. So we have this graph with the details we know about the current network, meaning the nodes in our organization, which is 1 peer, 1 orderer, marked by these 2 different glues. We have the 2 border nodes, and we have 1 external node from another MSP. And we have some basic information about the nodes on hover interaction, also some basic metrics about the communication between our nodes when hovering on the links. And we have this table below the graph where we have direct access to the Docker containers logs of our local organization's nodes. So this is what we can see here, just the Docker container logs. So next we'll look at the HyperSec's transaction view. So we have 3 main parts of this view. At the search parameters at the top, we have the interactive charts to explore available information about the transactions. And we have then a bunch of details. Each row is a transaction. So we can start selecting a start date from which point on we want to explore the data. In the topmost chart, we can now see 2 buckets which seem to have a bit more activity than the rest of the buckets. We can see the time window in which these buckets are and respectively change our search parameters to this time window. Time window is now going to be just around 3 hours small. And with the small time window, we can also change to a more fine granular aggregation. So we change here the bucket size to 1-minute buckets. And then we have a pretty frequent pattern, but 2 signs that are changing the pattern. So we have 1 MSP, which published a bit more transactions here. We can filter the MSPs here on the views. And also what then is somehow showcasing and highlighted up here is that the endorser proposal metric, so the transaction duration here increases significantly to more than 300 milliseconds with the proposition of these transactions. The table at the bottom now shows the transactions related to the currently selected time selection, and also gives some more details, also the direct link to the transaction. So that's it just for a quick video. I guess that's it about our HyperSec video. We can go on the last slide now. The tool or the current research prototype is available on GitHub. You can check it out there. We are currently experimenting with some different views, different data processing approaches. And I guess now it's just up to me to say thanks to everybody for the attention. And we are now happy to answer your questions. There's already 1 question in the Q&A. So Snorak Roy asks, how is the Docker container connected and how will integration differ when Fabric peers are running on Kubernetes. So maybe that's something you could answer, Benedikt.
Yes, so basically we're accessing only the local Docker containers. We have actually not tried it with Kubernetes. That is something you would have to experiment with on your own. But we're using a standard node package for accessing Docker. So you probably just have to change the URI, I suppose, and then it should work, hopefully. The most important part is that you actually have access to the Docker API, and then you can just access it by putting in the proper URI and the code, and then the backend is going to forward the request to the Docker node. Yes, and then you get the logs in the front end again. And of course, I mean, you're only going to be able to view your own nodes logs and not the ones of the other organizations, because you might not have permission for that. Okay, so if there are no other questions, I could also go again in a bit more detail on some potential for improvement that we noticed in the Hyperledger Fabric ecosystem on slide 13. So there are some missing metrics that could potentially be added as well. For example, on outstanding transactions, discarded blocks, or failed leader elections, which is something that's very interesting if you're trying to detect an attack, and also regarding vulnerabilities. So there is, of course, a need to have proper threat intelligence by version, and there is no really good source for that currently. And you also want to have chain code scanners for the chain code in other languages. So we used one that's used for Go, but there is no proper chain code scanners, for example, for JavaScript or something. So those are all development needs that the community could potentially fill. I see we have some more questions. Tayamul is asking, are you querying Fabric for data or collecting in real time? So how Hyperledger Explorer works is it has a basically real-time sync connection to Hyperledger Fabric. So each block arrives at Hyperledger Explorer as it is published on the network. So you have almost real-time or near real-time, I would say, connection to the network. And you also, for example, if a config transaction is published, you should get very shortly after that, pending some site processing delay, get a config notification in your user interface. So we're not doing on-demand queries, but we instead are syncing to the network live and then querying our sync database. So besides the sync delay, there is not much delay there. So it would be perhaps some seconds, but not more than that. And another question by Solomon Roy again. He's asking about the channels. So in the channel view, we actually didn't show that on the prototype and in the demo, but I can quickly go back to that slide. You can see that at the top, there is a channels tab in Hyperledger Explorer. So you can actually see the different channels there. And you can also select the channel that you want to view the transactions on. So the Hyperledger Explorer can store blocks and transactions for all channels that you have access to with your identity. So we can store it for multiple channels. Of course, you need to have access. So if the channel is encrypted for you, then Hyperledger Explorer can't really analyze much. So that's the prerequisite, of course. Okay, so I think we have reached the end of our time. If there are any more questions, feel free to contact us. You can reach us, of course, on GitHub or using our email addresses. If you just search for our name and University of Regensburg, you should easily find it on Google, for example. And yeah, so we would be very happy if somebody wants to, for example, contribute to HyperSec on GitHub. We are always very open and welcoming to contributions there. And we, of course, always try to contribute our own developments back to the original project. So we have made some pull requests to Hyperledger Explorer to improve the project. and are of course going to continue to do so as we have improvements in our prototype that are relevant for the main project. So it's very happy, of course, to do that. And yeah, that's it for our presentation. Feel free to contact us and have a nice experience at the conference.